Hello, this is Math with Beth, and we are going to look at absolute value equations and inequalities and how to solve them. So when you have an absolute value equation or inequality, the trick is you're going to end up having two separate equations that you're going to have to solve, because when you think of absolute value, if we did a very simple one, like what is the absolute value for 3, what this is saying isn't what is the absolute value of 3, because that is 3. We know that. It's saying what number could I put in here so that the absolute value would be 3? Well, obviously I could stick a 3 in there and it would work, but couldn't I also put a -3 in there? And since I'm doing the absolute value, it would give me 3. So that's why these absolute value equations and inequalities end up having two separate things that we have to solve, because of this idea that 3 and -3 would work in that equation. So just trust me, from now on, that's why I'm going to make two separate equations to solve. But I can only do that when the absolute value stuff is all by itself, like it is here. Do you see, for the next one, I'm going to have to move some stuff before I do that. So this one is ready. So what I do is I set up two separate equations. One of them is going to equal exactly what it says up here. So in this case, 4. And the other one is going to equal the opposite of that. So in this case, -4. And then you just solve depending on what is left to solve. So in this case, I'm going to add 3 and add 3. So my two answers, or my two solutions, are 7 or -1. So if you want to put an or there, you can. X equals 7 or it equals -1. Either of those would work, and you can plug them in and see that that is true. So like I said, for number 2, we're not ready. I need to get just this, the absolute value stuff, by itself before I can do what I did over here and set up my two equations. So I need to move this +3. And I also need to move that -2 out front, but make sure you understand that -2 is being multiplied. So I'm going to need to divide it. So I finally am ready to actually start the problem. I did all of that just to get the absolute value stuff by itself. So now I can say, just like I did over here, that I need to set up two separate equations, one where all of that equals 4 and one where it equals -4. Notice when I set up my two equations, I get rid of the absolute value signs, because that's what the absolute value signs are telling me to set up these two equations. So I'm going to subtract 1 and subtract 1. I'm not showing all my work there because hopefully everyone's okay with that. Okay, so that is how you always solve if there's an equal sign. Now, inequalities are these where there's not an equal sign, but instead a less than or a greater than sign. So these are similar, where your first step is to get this all by itself. But then when you go to set up your two different problems, one of them will look exactly like this one. But when you go to do the one where you're going to make that 7 a -7, you also flip the inequality. So instead of less than 7, I make this one greater than -7. So you have to switch both of those things. And then the next step is I need to figure out what word I put in between, because it is not always or. So how you figure that out is when you got that absolute value stuff by itself, if that absolute value stuff was less than a number, then it becomes an and graph. If that absolute value stuff was greater than a number, then it becomes an or. And this matters because when we go to talk about the final answer, the and the ors are important, because we're going to graph it on a number line. So in this case, since it was a less than, I'm going to make it an and. Okay, from here on out, we do just solve this nice and easy, but that and's going to be important when I go to graph my final answer. So I'm going to add 5 and add 5. So my final answer needs to be the numbers that do this and also do this. And sometimes there's not going to be any numbers that will do both of those things at the same time. And in that case, it's no solution. So are there numbers that are less than 12, but also greater than -2 at the same time? Yes. So I need to be less than 12, but not equal to 12. So there's my open circle. But I also need to be greater than -2. So that ends up being the numbers that are in between -2 and 12 are my final answer. So how do I write that? The best way I think to write it is just in an interval, which means I'm going to use either a parenthesis or a bracket. So open circle means parenthesis, -2, comma, 12, parenthesis. That means all of the numbers between -2 and 12, but the parenthesis means not including the -2 and the 12. So let's do that again, because I know that was a lot. So number 4, there's just one extra step. That's getting rid of that -3 in the very beginning. And since that -3 is being multiplied, I'm going to divide it. And since I'm dividing by a negative, I need to remember that I have to flip this right away before I even get started. So I'm going to put a star here because this is like the real start of my problem. I moved anything that was in the way so that now the absolute value is by itself. So now that my problem's starting with a greater than, this is going to become an or problem. So I'm going to say x plus 2 is greater than or equal to 3, or x plus 2 is less than or equal to -3. So remember, you flip this and change the sign. Subtract 2. Subtract 2. Now I'm going to graph it with an or in mind, and that's easier because that means everything stays. I don't need to worry about doing this and also doing this at the same time. So I basically just need to graph any numbers that are greater than or equal to 1. So that would be a closed circle going to the right, or the numbers that are less than or equal to -5. So all of these numbers are good to go, and all of these numbers are good to go. But now if I wanted to show that as an interval, that's a little trickier because there's 2 separate sections I need to describe. So this section is all of the numbers from -infinity to -5, including the -5. And then I put a U to say, and also all of the numbers, including 1, going to infinity. So that's how you say that. Let's do one more just to make sure we're getting the idea of this. This one is ready to start. So I say less than or equal to 9, since it's less than, and 2x minus 3 is greater than or equal to -9. So add 3, divide by 2. I don't have to flip this because I didn't divide by a negative. Add 3, divide by 2. So I need to graph the numbers that are less than or equal to 6, but at the same time, they need to be greater than or equal to -3. So less than or equal to 6, but also greater than or equal to -3. So it ends up just being the ones in between -3 and 6, but I want to include the -3 and the 6, so I use a bracket. Okay, that's a lot. Feel free to comment and let me know if you need to see more of these, or if you just want me to focus on just the equations first and then just the inequalities. But hopefully that was enough of a review if you've seen this before and just needed a little brush up. See you next time.